Hey everybody, how's it going? Great to see you too, Kris. Thanks. Yeah, we're going to be talking about Kubernetes and Kubernetes operators today. And I'm going to do I don't know, maybe 10 minutes or so of just kind of like an overview, setting the stage, and then we're just going to kind of do some live hacking. We're going to build an operator, and if Wi-Fi wants to cooperate in GitHub, I don't need any dependencies to pull down from GitHub. We should be good, and we should actually be able to interact with an operator in Go, deploy it to Kubernetes, and get in kind of glue all this stuff together. So as we go through our slides, we're going to be looking at pictures of mountains, because that's what I do. So yeah, this is me, Kris. I climb stuff, and I talk about Go. OK, so let's jump right in. Kubernetes and desired state. When I first heard about Kubernetes, I had no idea what it did. And I kind of got a really bad first description from a lot of people. They sort of talked about all the different components and all of these buzzwords and crazy names. And it took about 6 months for me to realize, oh, desired state is really what this whole thing's about, which is, as a software engineer, as an operator, I go and I declare something, please make this so. And then there's this layer of software that does its best to try to make that so. And if at any point that declared state is not so, it tries to reconcile that. And that's pretty much all Kubernetes does. What that state is completely arbitrary. Literally can be anything, and we're going to jump more into that a little bit more later. But real quick, who here has used Kubernetes? Oh, dope. OK. So the last talk I did, I was like, who here has used Kubernetes? And one person put their hand up. And then I was like, who here has not used Kubernetes, but for some reason thinks that's a good idea? And everybody put their hand up. And I was like, OK. So I'm not going to talk too much about Kubernetes then. OK, cool. So this is a diagram that I wish somebody would have showed me when I first started learning about Kubernetes. It's about as simple as it can get. You declare something. In this case, it's an application. But again, it can be any old thing you want. It talks to an API server. It sticks it in a database called etcd. There's this thing called a controller. That's just this loop that goes on forever. And it just reads that desired state. And if it needs to take action, it does. Whatever action is, it's an API call. It can be touching a file on a server somewhere, updating a record in a database. It doesn't matter what that is. It just does something. OK, so Kubernetes controllers. Let's talk about these and define these a little more in detail. And then we're going to talk about how operators are different than controllers. So the first thing I like to tell people about a Kubernetes controller is it implements watch. And watch is this construct that we got from etcd, the primary database that Kubernetes is built on. And with a watch, we're watching the entire namespace. So any object in Kubernetes that resides within a given namespace. Who here knows what namespaces in Kubernetes are? OK, most people. So any object that resides in a namespace, if something happens, if something changes, we're going to get this thing called an event. And that's sort of this event-driven declarative way of writing code. And then in our Go code, we can go and we can change it and make something happen. Furthermore, Kubernetes are nebulous. This is a really important part here. If you look at the controller manager, that's even more meta than this. But the deployment controller, for instance, in Kubernetes, all it does is manage deployments. What a deployment is up to you. It can be anything. It can be your business app. It can be other components of Kubernetes. Or it can be infrastructure components. It can be components that do anything. The point is that the Kubernetes controller doesn't really have any concept of what makes your component special. It's nebulous. As long as it fits this generic interface, we're happy to interact on it. And that's a really important defining feature of a controller. Furthermore, controllers are stateless. There is a little cache here, which we're going to create a cache in the form of a Go struct here in a few minutes. But the idea is that if you did go just destroy one of these at runtime, kill -9 it and drop the container, you should be able to bring it back up, and it should pick up right where it left off, because the state is stored in etcd. So stateless application, even though there's technically state that we care about, this is the stateless component of the broader stateful application. And then again, it takes action. Action can be anything. I have a real-life example I'm going to talk about in a few minutes, and we'll actually see an example of some sort of action. And then this is so critical. It reports status. I took action, and maybe it went well. Maybe it didn't well. Maybe it went pretty well, but not all the way well. And we have some sort of meaningful status. And as humans, we can advertise what these different statuses mean. Like this error code means this, or this status string over here means that. And we can have other pieces of software respect that status and take action if needed. If we get like a 200 equivalent for a Kubernetes object, then we know everything's OK, and we can safely count on whatever action the controller should have taken to have happened accordingly. So reporting status back to the stateful component in the system is another huge defining part of a Kubernetes controller. So this is going to be really intense, so I want to make sure everybody's watching the screen right now. Let's look at the difference between a Kubernetes controller and a Kubernetes operator. All an operator is it's domain specific. It's important to one concrete idea. I love this example. So let's say that we have a controller that it's called a database controller. And all it does is it creates some sort of database that's important to humans, and it updates it if it needs to be updated somehow. And ultimately, it's responsible for deleting the database as well. You can run whatever old database you want, Postgres, MySQL, MongoDB, WebScale, doesn't matter. So this controller would go and it would basically have CRUD on managing one of these databases. Now somebody came along and said, well, that's not enough. I'm a DBA, I'm a MySQL DBA, and I have to configure bin logs. I have to configure replication logs. I have to configure my slave replication status and the interval at which I replicate data from my master to one or more slaves, and I have to update the amount of slaves arbitrarily over time. And all of a sudden, we realize there's this huge space of management and managing a MySQL server that doesn't get encapsulated in that broader database controller logic. That's where an operator comes in. It's involved in doing all of the management stuff that like a person used to do. Like I'm gonna go manage this MySQL server and like SSH in and cat some text files. And we're gonna try to encapsulate that in the form of a for loop, hopefully in Go. So Kubernetes operator, we're good there? Okay. Here's an example of an operator pattern. I really like this because it's going to touch on the three things that I really want to kind of like hammer home here, which is the difference between a controller, the most nebulous, an operator, something that's domain specific, and a deployment, which is this fundamental component that's, for lack of a better term, relatively dumb. So the first square we have up on the screen is our operator.yaml. And in that, we define some sort of operator. Let's go ahead and continue with our MySQL example, because I think that's easy for folks to grok. So we define a MySQL operator. It's got some configuration values, just key value pairs, whatever. We deploy it to Kubernetes. It goes, hits the API server. The API server sticks it in etcd. And then this is a Kubernetes component. So this is written by the open source Kubernetes community. The controller reads this deployment and goes and does something. It takes action. And what it does is it spins up your deployment. And in this case, your deployment is a container running. And you're getting all of this like goal-seeking behavior of Kubernetes ensuring that this deployment is running. And it just so happens that that deployment itself is an operator for something else. In this case, it's an operator that creates another deployment. So we're sort of seeing this recursive behavior of using control loops to manage other control loops to take arbitrary action. And as a software engineer, you can go and you can write these operators that create deployments or touch files on a file system or update a record in a database. So I think this is a good example. Again, the deployment is just your app running, and that's it. OK, so why are operators important? So they're good for managing tasks and chores. From a DevOps perspective, who here is DevOps? Who here is just like, no way in hell I only write code? Who here is something else? Whoa, OK, now I'm curious. What are you guys? OK. So we all have chores in our life. Chores around the office, chores around maintaining our system, chores around watching our systems. And I'm sure you all saw Charity's talk yesterday. So these chores can be automated. And the traditional way of automating them was to like run a job in Jenkins and like click your button and hope for the best and like throw the ball over the fence and hope everything went OK. So these operators are nice because you get this goal-seeking behavior. You define it, and if something does go wrong after you've set it up once, it will try to fix that. So like you can try to like play like this game of cat and mouse with an operator. Like it's supposed to do something, and you go and like undo it like Gremlin style, and then watch your operator fix it for you. So it's actually pretty resilient. It's like a handy little task keeper that you can create for yourself. So anytime you have a chore around the office, around your engineering organization, you can potentially update it with one of these operators. I've said declarative and goal-seeking like 100 times already, so might as well say it again. They're declarative and goal-seeking. And furthermore, they're dynamic. And what I mean by dynamic is if we have an operator that's running, and we're going to do an example of this in a second, but yeah, if you have an operator that's running, and you want to change some configuration, as long as the operator code itself is sound, you could just change the configuration, and the operator code will begin to respect that automatically. You don't have to like stop the operator and create a new one. It'll just magically work. So as an operator of an operator, you can go in and you can like define whatever arbitrary configuration you want. It'll magically pick it up, and poof, you have changed your operator's behavior. Resiliency, I think, comes with declarative. In the fact that it's stateless. If you nuke this thing out of nuke this thing out of your cluster, Kubernetes should pick it up and deploy it again. Furthermore, they're interchangeable and modular. In the case of our MySQL example earlier, we could have had one operator that had a very, very finite set of tasks. Its only job was to ensure we had 4 or 5 or however many slaves you defined running, and that's it, and that's all it did. And then we said, that's not good enough. We need to come out with another version of our operator that actually does a bunch of other stuff that's important to us as well. So we could keep our configurations the same and then just flop out a container. And again, as long as it's speaking that same API declared in the CRD, we're going to be able to move that in, and our whole system's going to be much more modular. OK, a real-life example. Cluster API. Who has heard of this thing? Gosh, nobody here? 1 person, 2 people, 3, 4, 5? OK. So this is one of the projects that I've been working on in upstream Kubernetes. And to me, this is really interesting because it uses software and these operator patterns to manage infrastructure. And it's cool because you're actually managing the infrastructure that your software itself is running on. So you have like this interesting game of which comes first, the infrastructure or the software, and how do you manage yourself and how do you create yourself. So it's pretty cool, and we had to borrow some ideas from the first compilers and how they had to compile themselves to get this stuff running. Anyway, it's declarative infrastructure. I want 4 machines in my cluster. I want 5 machines in my cluster. I want 6 machines in my cluster. And it's that same operator pattern of I go and update a record in a database. The operator reads that, and then it goes and sends an API request off to a cloud provider and creates a machine for us. There's an example of this in KubeCon. I put a video. Who knows what KubeCon is? I make people talk about unicorns. It's written in Go. It deploys Kubernetes. It's really awesome. If you get a chance to check it out, it's pretty cool. There's an example of this working in Amazon with KubeCon. And you can go and you can actually create a server simply by changing a number in a YAML file. And poof, your Kubernetes cluster automatically scaled itself. We have a concept of machines, and we have a concept of cluster in there. So this is what it looks like. We have a machines.yaml that defines a server, and it's got information like which SSH key do you want to use, and what size server do you want, and what operating system do you want to run on. We send a concept of this up to Kubernetes. Kubernetes saves it. We have an infrastructure operator, cluster API operator, that reads this and then goes and forms together the EC2 request and sends a request to EC2 that says, please give me a server. Literally, we're creating a server. That's why it says literally a server there. And we can scale our cluster up and down. So that's a really great example of a time where operators came in and helped me. It wouldn't be a Go talk if I didn't talk about a great book that I had read. And I was like, man, what's a really awesome book that I read recently? And so last year, I read this really great book called Cloud Native Infrastructure. It's written by me. You guys should check it out, and it talks about everything I just mentioned. And all the examples are written in Go. So if you're an infrastructure software engineer and you write Go and you use it to manage your systems, this is probably going to be a really interesting book for you to check out. Also, I get 4 cents every time you buy a copy of my book, so that adds up. I'm waiting for my first cup of coffee. Yes, my book bought this cup of coffee. OK, so let's start hacking. I purposely kind of left my demo vague because I want folks to kind of get involved as they start hacking. So feel free to jump in and ask questions. And I kind of have a little bit of an idea of what I want to do, but we're happy to change this operator and kind of make it do whatever we want. And I'll be using this new tool called Operator Framework. I did a TGIK episode on this last week. Who knows what TGIK is? It's a thing we do at work. Every week we do a video series on some tool in Kubernetes, and we explore it and hack on it and open it up. And usually folks who wrote the tool join the call, and it's a pretty interesting way to learn about new tooling in Kubernetes. So anyway, I did an operator framework TGIK, and I really liked it, and I thought it was good, and that's what we're going to talk about today. if you look at what the operator framework does, and we can go into detail and actually explore the vendor directory later, but these are the ones that are important. So while you read that, I'm going to get a sip of water. Who recognizes a package up there? Which one? Client Go? Yeah. So Client Go is a Go library that allows you to talk to the Kubernetes API. The other three are really complicated API management packages that help you deal with building out an API, which is just like a version struct in Go, and then managing that API. And there's some like helpers and other bits of functionality in there. The API machinery stuff is pretty interesting. It allows you to version your APIs and write conversion logic between them, since Go is statically typed. OK, let's jump right in and do a demo. I'm like trying to get as much water as I can before I start getting both my hands busy. OK, cool. Any questions so far? Come on, somebody ask me a question. Cool. So I created this thing called a puffin operator. Because we're in Iceland, and puffins are like the touristy thing, so we're going to talk about puffins a lot today. What the puffin operator is going to do, we don't know yet, but it's Go, so anything we can do with Go, we can do with our operator, which is pretty convenient. And to start off, I want to show you guys kind of like where I am and what I have set up, more importantly, what I don't have set up, and then we can sort of figure out what we want to do moving forward. Anyway, here is our good old main.go. So we look at our main function. This is a pretty common, like if you've looked at a Kubernetes controller before, this is going to look really familiar. I just want to be really clear that Kris Nova, myself, is not prescribing this as a good pattern in Go. I'm just saying that this is how the rest of Kubernetes does things, and it makes sense to keep everything kind of the same. So opinions are my own. So anyway, if we look at what we do here, we call this print version function, which just calls this function right here. It just uses logris and echoes some stuff out. Today, everything we're going to do, I'm going to try to pull back as far away from any magical packages as possible. So I'll be using the Go standard library for most of the coding I'm doing so that everybody knows exactly what's going on. So anyway, we call print version. We define a resource, which is Kubernetes. I called it Kubernetes.iceland.is. And we're in the v1 alpha 1 version of our API. And we're actually going to look at the struct that makes up this API in a little bit. Who knows Kubernetes APIs in Go? OK, so it's like every time I ask one of these questions, more hands keep going down. So I'm like kind of hitting the nose just right here. OK, cool. So kind is equal to puffin, which this is something. This could be MySQL operator. This could be machines operator, like the cluster API example I gave earlier. This could be like you and your chore and whatever you want to manage. In this case, I just did puffin because puffins are cute. We define resync period equal to an int of 5. And we say SDK watch, SDK handle, and SDK run. If we look at this SDK package, it's basically a convenience package. Why can I not go to this package? Oh, yeah, thanks. Good thing I have like the JetBrains folks here. I should be able to. OK, there we go. I promise. OK, here we go. OK, so we're looking at the watch. This was written by folks at CoreOS, now part of Red Hat. And this just sort of like gives you some tooling and conveniences for building a Kubernetes operator. Again, you don't have to do it this way. You're welcome to write your own packages. I just did it this way because all the noise is taken care of for me, and we can get down to the nitty-gritty. So here we have a run, which just loops over our informers, calls run, and passes in a context. And then we do context.done, and we exit the run. Going back to our main.go, we can see that for this SDK handle, we pass in this thing called stub new handle. If we actually go and see what handle it expects this thing called a handler, which is an interface, and we look at the interface. And it is a real simple interface. It has a method called handle, and it takes a context and an event. And if we go and we look up what an event is, this is where we start to enter Kubernetes land. An event is this thing called a runtime object, which is just an arbitrary Kubernetes object. And we have this thing called deleted, which is a bool that says if it was deleted or not. And then if you look at object, it's just defined here. It's just a runtime object. A runtime object can be a deployment, a pod, a service, an egress. These all sort of like, I don't want to say inherit. What's the word I'm thinking of? Somebody not embedding. What's that? No, it does not implement. When you put a struct in another struct. Embed? Composition, that's what it is, yeah. Sorry, I'm like up here telling you guys how to write Go, and you're telling me what to do. Cool. So anyway, we call handle, and go back to our main.go, and we have this thing defined called new handler. And if we look at our new handler, this is where we're going to start writing code, and this is where we're going to be spending most of our time as we look at this program, is here. We have new handler that returns a pointer to a handler. We have type handler struct that says fill me, that we're going to put all kinds of stuff in here. This is effectively going to be our cache in memory. So we don't want to put anything there that will not be able to survive a catastrophic outage. So these are here for performance and optimization, and we shouldn't really be relying on anything here in the handler struct. And then down here, we have handle. I have a little comment here that says we should write down everything we want to do today so I don't forget. So let's figure out what we want to make our handle do, and then we'll talk about these select and switch statements down here. I'm going to comment this out. I will respect our context once we're done, because we're going to munge everything up into the default up there, because I was like, Peter's going to kill me if I don't respect context.done. So moving down to our switch here, we have a type switch on event object. And the first one is we have a pointer to this thing called v1 alpha1 puffin. This is our API. So this is a struct in memory. The way that we version these structs is we have the version, and then we have its type, which is puffin. And if we go over here on the left, we have APIs, Kubernetes, v1 alpha1, types.go, which types.go is like a really important file in the Kubernetes ecosystem. If you're exploring an APIs directory, types.go is really where you want to go, and you're going to spend most of your time, because this is actually going to define what this thing is that we're creating. In this case, we have a spec that says fill me, and we have a status. Let me see if I can turn my brightness up real quick. There we go. That also says fill me. And if you look at the broader construction of Puffin, we have a Puffin spec and a Puffin status. So as we take some action on whatever this Puffin thing is that we have yet to define, we'll actually be able to receive that over here in our handler. And we can actually do a couple of different cases here. Like we can do case is equal to a pointer of v1 alpha1. We can do puffin list. And then now, if I come down here, we could do printf. We have a list of puffins, and we'll do a string, and I'll do a new line at the end. And this O variable is now a puffin list. We can't do name, so what do we want to do? We'll just do okind, since that's a string. And let's do a new line here. Cool. And so anyway, this is like that watch that I was talking about. So anytime some event happens in our namespace, this handle function is going to get called. And then the whole reason we have this type switch down below is so that we can sort of monitor all these different types that we're going to be defining in our namespace. So we can really start to build out complicated logic on top of Kubernetes. And we know that we're going to get the same features of the rest of Kubernetes that's made the project so successful. But we're going to get that for us and for our software, which is pretty handy. So anyway, if we come in here to v1 alpha1 puffin, it says we have a puffin. So is everybody good so far? You understand the API, how it fits, and when we're going to call the handle function? Yeah? Cool. Let's run it. So I made a makefile. It's really simple. It uses the operator SDK binary, which literally just wraps up a bunch of shell scripts in exec. So nothing fancy going on there. Like there's some bash if you want to go look at it. And then other than that, most of these are pretty straightforward commands. We do a Docker push. We have this one here is probably the most magical. It's called operator SDK generate K8s, or K8s. And all that does is it's going to read whatever we have defined in our types.go here. And it's going to create a YAML file here that respects that struct in Go. So it's going to map the two together. So as we start to flesh out our struct, we're actually going to start to make this much more mature, and this becomes our declarative point, and we can define one or more of these different flavors of puffins moving forward. So anyway, we can go ahead and we can do make generate. Did I spell generate wrong? Is my makefile messed up? I wrote this like an hour ago. Oh, I don't have make generate. What do I want to do? Make API. I don't know why I call it make API. OK, cool. So now it's calling operator generate K8s, and it's going to do our code generation for custom resources. Who here knows custom resources in Kubernetes? OK. So basically, I just created a custom resource here called Puffin. So now I can define one or more puffins in Kubernetes, and then our operator is just going to be able to look at these puffins. So a custom resource is one specific concrete puffin, and then the custom resource definition, or CRD, is this sort of ambiguous definition defined here. So after we do a generate, we've updated our YAML. We can now do make, I think it's make container. So we're going to do a build, which is going to compile our Go code, stick it in an Alpine container, poke a hole in the container, and it's going to push it up to our Docker registry here. So what are we, 3, 5, 6 out of 35 megabytes? I'm going to like slowly pace over here and like slowly pace back while we wait for this Docker push. And then after this is up, we're going to be able to go in and actually define various parts of these objects in Kubernetes, and our operator is going to be able to go and look at them. This is the deployment. It's called a Puffin operator. If you come down here and you look into containers, it's going to say it pulls Kris Nova, me, Puffin operator, and the latest tag. Image pull policy is always, meaning that in order for me to re-pull my Docker image, I have to go in and just nuke the pod. And then Kubernetes will re-pull that, the scheduler will, and run it for us. And this is just telling us that we want one replica of our deployment here. And then the deployment will then create one pod running in Kubernetes. OK, so while that's pushed up there, we can now kget PO. Does everybody know about the K and the PO and the no and all that stuff? OK, so all I did was alias K equal to kubectl, and kubectl is just like the command line tool here that lets you interact with Kubernetes. So kget no is actually the exact same command as kubectl get nodes. And we're running a kubecorn cluster right now, and if I wanted to create more nodes, I could actually go and just create a YAML file, because we have kget machines that are defined here, which is pretty handy. And this, again, I made this cluster for TGIK, and I'm just still using it, but whatever. OK, so anyway, let's look at our pods that are running. We have this BusyBox, and we have this Puffin operator. And I think the reason we have this BusyBox is because when you first install the operator framework and you actually deploy this thing right out of the box, the first action it takes is to create a BusyBox. So I think we can actually delete the BusyBox pod, and it should just magically go away and not come back. The goal here is for this thing not to come back. That's like Kubernetes is so good that like sometime you have to like look around and see why things are being recreated. K get delete. K delete. Does everybody know about the different various things you could do with kubectl and how to delete resources and create them? And I don't want to like preach that stuff if I don't need to. OK. So let's see what happened now. OK, so it's terminating, and it's not recreating. OK, good. So let's look at our logs for our Puffin operator that we just deployed to Kubernetes after we delete it, and it'll re-pull. So delete that pod. You can see Kubernetes is creating a new pod that has a different hash here. And that, like what's going on in the background right now is Kubernetes is actually pulling down that container that we just pushed up a second ago. So we can get logs for it. -f to follow. We have a Puffin. Example is the name of our Puffin. And if we come here, we look at our cr.yaml. Name is equal to example. So guess what would happen if we came in and who wants to pick out a name for a Puffin? Chad. Call it Chad the Puffin. I like Chad. So what we can come in now is we can kget. I think we can do kget puffins. This would be so great if this works. OK, yeah. Kget puffins. So we can edit this or we can redeploy it. So I'm going to create -f deploy. What do I want to do? cr.yaml. And that cr.yaml is just this file here that we just edited. And we should be able to kget puffins again. Puffin Chad is invalid. Lowercase alphanumeric. Sorry, Chad. All right, let's try this again. Create -f deploy. Puffin Chad is created. Kget puffins. OK, so now we have example in Chad. And let's get our log command back up. And look, we have 2 puffins. We have one puffin named Chad, and we have a puffin named example. And I'm sure you guys can, you folks can imagine what would happen if I delete puffin example. No, we'll keep Chad. We'll keep Chad. OK, and so now we can get our logs again. And we should just only see that we have a puffin named Chad. So there's some interesting behavior going on that I want to point out, which is if you notice, this is sort of like giving us a new log line every couple of seconds. This is where that cache comes in. Remember we had that struct called handler, or I think it was handle? And then, yeah, it was handle, which was of interface type handler that had a function called handle, or a method called handle. But anyway, in memory, we could flip a bit that says, yes, we've done something with this puffin, with the puffin named Chad. Otherwise, we're going to continue to watch and get this event every 5 seconds. And if we go and we look in our main.go, we actually defined resync period is equal to 5. And that's what we're seeing here. So the first time you write one of these operators, it's kind of like an interesting paradigm to like, I thought that this thing only happened whenever there was an event. But like, no, it'll actually pull all resources every resync period so that you can resync every time one of these resync cycles restarts. So if you do something with Chad, and you only want to mess around with Chad once, you better put something in memory that says, OK, we've already operated on a puffin named Chad. So you can really build out some like complex software patterns here so that you can like maybe only create Chad once, but ensure that Chad is in the state that you intended Chad to be in over time. So what we want to do now is let's like actually go and let's define like what makes a puffin a puffin. So we go to types.go. So let's define a spec here. So what do we want to, let's pick an arbitrary field we can add to this struct. Color, wings, does he have wings? Let's do, I'm trying to think of a good one. Let's do color, why not? We'll have different colored puffins. So that'll be of type string, and then we want to define this JSON. This is kind of interesting. You want to define the JSON here in your field, otherwise your YAML is going to be wrong, because that's the thing. And we want to say, this is color, lowercase. I think that's the correct syntax. And then for our status, let's do another string. Let's just do, we'll just do puffin status string, and we'll call it status. And we'll make that of type string. And that way we can actually get the status on this puffin. So as we come here, let's go look at our handler code now. And let's, oh, sorry about that. Let's actually do a map here. We'll call it puffins. We'll make it not exported. Puffins printed. And that'll be a map of string and bool. And when we do new handler, let's initialize our map here. What was it? Puffins printed is equal to make map of type string bool. Trailing comma. Cool. So now we have initialized a map, and we can come in here, and when we have a puffin, we can actually do if h dot puffins printed o dot name, and actually let's do OK here. Not OK. Gosh, I haven't coded in so long. Is that syntax right? Somebody told me my. OK, what? Thank you. Yeah. There we go. OK. So if OK, then we don't want to do anything, so we can just move on here. Otherwise, or it's not OK. So we actually, the logic is backwards here because we're doing a not OK. We want to go ahead and print Chad. So I have this this package here called puffin, and in here we have a exported function called printPuffin, and it just prints a picture of our puffin. And it calls from printline on our puffin. Which I actually just found this out today with Goland. If you put like some erroneous new lines here, you actually yells at you, and it's like, no, you have redundant new lines, which is a new thing for me. And at first I kind of was like, why are you doing that? And then I was like, actually, no, that's probably a good thing, because you really want your stuff to be nice and neat. So anyway, so if it hasn't been printed, let's go ahead and call puffins. Print puffin. And that's what we need to do. And we'll go ahead and we'll do h.puffins printed dot o name is equal to true. Bam. So that way, every time it comes through, we will print a puffin the first time only. And let's go ahead and take this. And oh, we want to update our status as well. So we want to do or actually, wait. It's o dot status, puffin status. We called it status, yep, is equal to printed. We'll do s. Printf, bam, and then we'll do the name of our puffin that we just printed. O dot name. How am I doing on time, by the way? Okay, cool. Cool. So we're going to update our status is equal to printed Chad, and then we want to do SDK.update. Again, this is cool because it takes the runtime object interface. So this makes it really easy for us using this SDK package because I can just pass any old object in here, and it'll actually go and update that to Kubernetes just by doing SDK update here. So we can pass in O, and now our logic's done. So we get a puffin that comes in every 5 seconds. If we haven't cached that we've printed it already, it's going to print out a puffin, nothing more. It doesn't say it's their name or anything. And then the status is going to say that it's printed Chad. Otherwise, we're going to update the status to skipped Chad, or skipped whatever the name happens to be. So we'll copy this. Bam. And we'll do an SDK update O again. Bam, bam. So we come back here, close out of our logs, do make API, which again, this is updating our YAML and our CRD based on what we have defined in Go. If we look at our make file, we now want to do a make CRD since we've updated the CRD type. Oh, we want to deploy that, delete it first. Okay, get CRD. Okay, delete CRD. And now we can do make CRD. Cool. So now the new puffin definition is there. And we can do a make build. Actually, it was make container. I always forget my make target names. So we're updating our Go code now because we've updated our definition in Kubernetes from the YAML that we automatically generated. 36 megs. Come on, don't do the whole thing. Okay, we have to like come up with some fill now. Anybody got any good jokes? Yeah, totally. Does that help? Cool. And then we can come into and we can add status and stuff here, although I think it's redundant. I don't think we need to. Waiting for this to push, and I guess what we can do is get our delete command ready at least. Save a little bit of time. Because remember, we're going to, oh, it's done. Wait, is it done? Let's grab this. Exit. Yeah, it's done. Okay, so now we can do k delete PO, the name of our puffin operator pod. It's been deleted. K get PO. Bam. Container creating. K logs. Name of our container. -f. Okay, so it's starting the puffin operator. We have a puffin named Chad. Let's make sure that's still there. Okay, get puffins. Puffin not found. Okay, puffin not found. Let's create our puffin. When we deleted the CRD, we deleted all of the records of it as well. So deploy, okay, create -f deploy /cr.yaml, recreate Chad. Cool. Okay, get puffins. I love every time I say that. Whoa. Yeah. Gosh, you all are like quick. What did I? Kris Nova, and then we're in puffin operator. Now let's try this again. Chad. Oh, okay, so that was really fast. OK, so we have a puffin named Chad, and then we have a puffin. And if we kget puffins, OYAML here, we should see our status. If I did it quick enough, status, dang it, we missed it. It says skipped Chad. But for some point, there was a while why the status was printed Chad. So anyway, we can come in, and we can do arbitrary logic, and we can actually build a Kubernetes operator to do whatever we wanted to based on whatever we define here in Go. I mean, to me, like, that's all I really needed to see to kind of like start. My brain started to go crazy and was like, I'm going to write things for Terraform, and I'm going to like write things to like feed my dog, and start to write operators for everything. Does anybody have any questions, or do they want to see anything else? Or I can get off the stage here. The question was, does this status come up when I do kget puffins? I love how we're talking about puffins right now. No, you don't. Can I do an O-wide? Which version of Kubernetes am I running? This is just version, right? Yeah. 1.10. I'm wondering if that is because we don't have it defined in our CRD here. I bet if we... Sorry? I'm sorry, I can't hear you. To third-party resource? I think it went from third-party resource to CRD, didn't it? Oh. I'm pretty sure CRDs came second. OK. Anyway, I think if we did status here, and then status is equal to we'll just do that for now. I bet we could probably get a status in there. But then it would involve deleting the CRD and recreating it. Anyway, any other questions? How would you unit test this? Beyond unit testing? So that's a great question. And the way that Kubernetes solves sort of testing this type of behavior is they have a really complex end-to-end suite. There's an open source tool called Sonaboy that goes through and will run the Kubernetes end-to-end suite and report back on if this was, it reached the desired outcome that we declared, and does all kinds of things like actually deleting a resource and making sure the operator does what it does and does the advanced checking there. There's some ways we could have written unit tests, like here, if we would have created a, where's our handler? We could have put a unit test here in our stub package that effectively would have passed in one of these puffins, and there's a way to synthesize the Kubernetes API just in memory so that you can actually do an update and then just check and see, like, we gave it a puffin with this type of name. Does the status equal, what we expected the status to be? And just do a sanity check and validate that your handle function works accordingly. Another pattern that's pretty common is you'll see handle, and it'll, right here after this case statement, you'll actually see this will enter another package with our context immediately. And then that whole other package is just built around this idea of like unit testing itself and having this very clearly defined, you give me a puffin, I give you a puffin and a puffin status. Any other questions? Yeah? The puffin code? Yeah, as soon as I can hit GitHub. Yeah, so it'll be called github.com/KrisNova puffin operator. Yep. And if anybody wants to see like a more detailed sort of definition of the cool stuff you can do with the framework I was using, there's actually a way you can like do a new and like run it locally, and it actually makes this whole experience a little bit better. I just wanted to show it up in Kubernetes because I feel like that glues everything together for folks mentally. But I did that TGIK on it as well, so you can go in there and really see how the operator framework and the operator SDK Go program works. Any other questions? One more time? If you send non-valid YAML, the Kubernetes API will yell at us. So if we come here to CR, and we'll just pollute our YAML file there. We tried to deploy this. Where's our deploy command? Right there, error, expecting YAML to JSON conversion. The way that it works is I think it converts the YAML to JSON and then takes the JSON and marshals that onto a struct. So there's a lot of back and forth kind of going on there. That's why you need those JSON tags. Come on. Somebody's got a hard one for me. Where? Right here? What's up? Oh, sorry, I didn't see you. Scaling to 8 or 10 million puffins. No, this is a great question. I'm so happy right now. And this answer is more Kubernetes. Like this applies to all of Kubernetes, not just puffins here. As we start to create that much data, we're going to start to push the boundaries of the underlying data store. They've done a ton of work into etcd to like give it the same construct and the same type of behavior. Once you get to a certain scale, though, like you start getting into all those complex databasing issues that you see with all the other large DBs. What the exact boundaries of etcd are, I have no idea, but I can go Google that right now if we want to. But yeah, that's going to be our first constraint we hit, is going to be what etcd can do to keep up. Yeah? Let's do it. Let's do it right now. So the question was, how easy is it to scale the operator? So all we would need to do here is get our, remember we had a deployment called the puffin operator deployment. We can edit the puffin operator deployment in our text editor of choice here, Emacs. Come on, that was a joke. OK, edit, deploy. There you go. Bam. I really do use Emacs. OK. So we can come down here to replicas, and let's just change this to, I mean, we can really, let's do this. Why not? 5,000. Yes, they're all going to get Chad. Yep, they absolutely will. So this is why we saw replicas equal to 1. So if we wanted to distribute our operator workload horizontally like this, so if this was taking action, not just printing puffins and standard out, but if it was like hitting APIs or something, we really would have just like screwed up and like broke the internet. But the operators would then need to be like responsible for implementing some sort of crazy concurrent Go locking between the two of them and making sure that one operator gets a message at a time. A really cool pattern that I've seen folks do in the wild is they have operators that create like a special hash in memory, and then they'll only operate on operator objects that have that same hash. So that way you can sort of start to separate your load that way, and you can say like, oh, I'll give this the unique tag like operator 1, and all the operator 1s will only operate on those objects. Otherwise, they just ignore it and move on. So clever ways of tricking it there. But if you're writing a distributed operator, you better have a damn good reason, because most of the stuff should be pretty simple and pretty cut and dry. Yeah. Kubernetes operators? Are we all going to go write operators now? Cool. OK. Well, if nobody has any other questions.